is the decimal number. You have to convert it into hexadecimal number. You have to divide this number by 16. Okay, and you will move from MSB to LSB. Okay, you can write this decimal number to hexadecimal number like this. Okay, this is your decimal number and this is your hexadecimal number. So when you want to convert this hexadecimal to decimal, you have to use a weighted sum of all the numbers. So what is the weight? Weight is 1, 2, 3 like this, 0, 1, -1 and -2. These are the weights. And we have to multiply it by base. So what is the base? Base is 16. So this is the conversion from hexadecimal to decimal number system. But when you move from decimal to hexadecimal, you have to divide that number with the base of that number. Okay. So the base is 16. So you have to divide it by 16 and you have to write your number into MSB to LSB. Okay. Clear? And after this decimal point, you have to multiply it by 16. So we have seen these conversion part in the last session. Then we have started the codes. We have seen the BCD codes. Then we have seen the advantages of BCD codes in the last session. Then we have seen the access3 code in the last session, and we have represented how you have to represent these numbers from decimal to access3. So you have to add 3 in each letter, okay, or each number, and you have to represent that number in 1248 formula. Okay, so it is equivalent to 4-bit binary numbers. Clear? Then we have seen the gray codes and how these binary numbers can be converted into gray code. We have seen in the last session. So when you want to convert this binary number into gray code, you have to represent this binary number as it is. First digit is represented as it is. Then you have to add 1 to the next digit. Okay. When you add 1 to the 0, you will get 1. Okay. Then you have to add this number with the another number. So 0 is going to be added with 0, it will give you 0. 0 is going to be added with 1, it will give you 1. Then 1 is going to be added with 0, you will get 1. And you have to represent this number from this MSB to the LSB. Okay. 11011 is your gray code. Clear? Then we have seen this gray to binary conversion. Okay, so this is the gray code. Okay, you have to convert it into binary. So first digit is represented as it is. Okay, then you have to add the result of the first digit. So 1 plus 1 is 0. Okay, then again this is 0 is the result. 0 plus 0 is 1. Okay, then again 0 is the result. 0 plus 1 is 1. Then again 0 plus this 1 plus 1 is 0. Okay, and 1 is carry. We cannot represent the carry in this case, and we have seen that this number can be represented like this. Okay, 10010. Okay, in binary form. Then we have seen alphanumeric code. ASCII codes can be represented as alphanumeric code. So 128 possible characters should be there in alphanumeric codes. Okay, 7-bit of code can be represented as alphanumeric codes. So when you want to transmit some data, so these alphanumeric codes are very much essential to transfer the data from one place to another. So then we have seen the binary addition. So how this binary addition is to be performed. We have taken the sum problem right here, and you add any numbers with 0, it will result you 0. When you add any numbers to the 0, it will give you 1 and carry 0. Again this 1 plus 0 is sum is 1 and carries 0. And when you add 1 with 1, it will give you a sum as 0 and carry is 1. Okay, so we have seen the addition example right here. So how you can add two binary digits. Okay, so this is the binary format of one number. You have to add it with another binary number. So this formula can be applied in this particular example, and we will get the result according. From 0, you will get a 0 result. There is a 0 borrow. When you subtract 1 from the 0, you have to take one borrow. Okay, and difference is also 1. Again, you have to subtract 1 from 0. You will get difference as 1, but borrows 0. Okay. Then 1 minus 1, your difference is 0. Okay. There should not be any borrow in this case. So next, we have seen the example part right here for the multiplication. Okay. When you multiply any numbers with 0, it will result you 0. Okay. As you can see right here, all the values are 0. When you multiply 1 with 1, you will get a 1 output. So this is a simple multiplication, as we have seen how you can multiply in decimal number system. Same is to be performed right here. When 0 is multiplied with any number, it will give you a 0 result. That's why this complete frame is 0. Okay. Next, again, you are going to multiply this 0 with all these numbers. So that's why this all are represented with 0. Next, you have to multiply by 1. So as it is, this particular uh, number, this binary number is represented as it is. Okay. Again, you have to multiply it by 1. Same number should be repeated right here. And if you multiply with 0, it will result you 0 output. Okay. So there is no need to multiply by these three bits because they are already 0, and you can find out the sum of all these contents. So 0, there is no addition part right here, so that's why we have represented 0 as it is. Again, 0 and 0, there is no digit point right here, so we again put this value as 0, then 0 0 0, and there is no value right here, so we will put 0. So in this manner you have to add the all the values. Okay. And now afterward, you have seen 1 is to be multiplied with all these numbers. So any numbers, you have a decimal number of 12. Okay. And this 12 number can be represented in binary as 1248 formula. Okay. If you want to represent 12, how you can represent 8 plus 4, 12, then 0 0. This is your binary. Okay. When you want to convert this number or into ones complement form, what is the ones complement? Ones complement is you have to use the complement of the number. Okay. So if I take 1 and I will take the complement, okay, I will take the complement of this 1. So what is the output for this complement? 1's complement is 0. And if I take 0 and complement this number, what is the output of this number? 1. Okay. So 0 should be converted into 1 and 1 should be converted into 0. Okay. If you want to find out the complement, 1's complement of this particular number, okay, you have to complement the whole number. Okay. So how you can represent this number? 0011. Yes, you are right. So when you want to complement this number, you have to represent 1 to the 0, and 0 can be represented as 1. Okay. So these are the ones complement. When you want to perform the twos complement, okay, twos complement, you have a number 12 in decimal that can be converted into binary like this, and we have represented the ones complement. Okay. 0011 as a ones complement. This is ones complement. Okay. And then we can add 1 to this number. When you want to add 1 to this number, it is known as 2's complement. Okay, so how you can add 1 plus 1? Quickly give your response. 0. 1 plus 1, 0. And 1 is your carry. So 1 plus 1 again is, quickly, 1 plus 1 again is 0. Again you take a carry. Then 1 plus 0 is 1 plus 0 is 1. Okay, and we will take the value 0. So this is the 2s complement. Okay, first we will discuss the OR gate, then we will discuss AND gate, then we will discuss a NOT gate, then NOR gate. Okay, so we will discuss basically these basic gates right now. Then in the next lecture, we can see all other gates, universal gates, and so on. Okay. So how you can show the symbol for OR gate? OR gate has two input and it is represented by this symbol. Okay. One input, let's suppose that it's A input, second input is B, and its output is C. Okay, so this symbol is represented as OR gate. Okay, how you can represent AND gate? Two inputs are there for the AND gate, and you can represent this AND gate like this. One input is A, second input is B, and third is C. Okay, what is NOT gate? How you can represent it? This is the symbol for NOT gate. This is the symbol for NOT gate. Okay, so it has the input A and it will give the output as complement of it. What is the NOR gate? Just take the OR gate and add NOT gate to it. It is known as NOR gate. It has the two input A and B and it gives the output C as complement. Okay. So now understand the mathematics behind these logic gates. First gate is OR gate. So OR gate can perform the addition part. A plus B is equal to C. AND gate will perform multiplication. A into B is equal to C. NOT gate will perform the complement. A is equal to A dash. Okay. And NOR gate will perform the addition part and we will take C as complement, output as complement. Okay. It will perform the addition and what will we get at the addition side, it will complement whole the result. Okay. So when you want to show the OR gate, you have to take the input as 0, 0, 0, 1, 1, 0 and 1, 1. So why we have taken like this? 0, 0 means it is input as 1 and this is input as 2. As you have seen in the 4 bit of binary number, you can represent 4 bit of binary number as 1248. When you want to represent 2 bit binary number, it can be represented by 1, 2. Okay. So place your value like this. Okay. If you want to represent 1, this is 1. If you want to represent 2, this is 2. If you want to represent 3, this is 3. If you want to represent 0, then output all values to 0. So this is 0, this is 1, this is 2, and this is 3. Okay. Now you have to perform the addition. So 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0. Okay. So this is the addition part. This is the addition part and you have to use it as 1 also. Okay. 1 plus 1, 1. Okay. When you want to perform multiplication, Okay, same concept you have to use. Okay, but in case of addition, you have to multiply this. Okay, so same 0, 0, 0, 1, 1, 0, and 1, 1. When you multiply 0 with 0, you will get 0. 0 multiply with 1, you will get 0. 1 multiply by 0 is get, you will get a 0, and 1 multiply by 1, you will get 1. So in any of the case, when you take any input as 0, it will give you output as 0. Okay. Okay, now come to the next part. This is your NOT gate. This is your NOT gate. In NOT gate, you have to take one input. Okay, either you will take 0 or you will take 1. Okay, when you complement this 0, you will get 1, and when you complement this 1, you will get 0. So this is the output for NOT gate. To the next part. In this particular NOR operation, you have to take the two input. Either your input should be 0, 0, 0, 1, 1, 0, or 1, 1. Okay. When you take both the input as 0, you will get output as, you have to perform the addition part right here. Okay. This is a NOR gate. Okay, you have to perform the addition part first. 0 plus 0 is 0. Then you have to take the complement of this 0. So what is the complement of this 0? Complement is 1. Then again 0 plus 1. Your output is 1. Then again take the complement. It is giving you 0 as output. Okay. Then 1 plus 0 is 1. Take a complement and its output is 0. Then 1 plus 1, it will give you output as 1, and take a complement and it will give you 0 output.